Hello everybody. In this video we are going to review the requirements engineering lecture. This lecture was quite of a dense one where I discussed first why you should do requirements and then how you can write those requirements, and I mostly focused on UML, a very common language for that. I started with this very famous joke that it is pretty hard for customers to really know what they want. It is pretty hard for us as a software developer to build what they need, so on and so forth. So you can see that this is the customer initial view, but at the end this is what the person needed, and all the other steps are basically what we as developers we build over time. So this is basically to tell you that requirements engineering is quite challenging. Then we did some sort of exploration in the lecture. Let's think about requirements for a software like Brightspace, because we know the domain a bit. What does it need to do? What does it not do? So on and so forth. And then we went to this idea of doing requirements engineering, right? So we want to do software in a systematic way, and we want to collect requirements in a systematic way. And then I showed you basically 4 steps that you have to do when doing requirements. So the first one is about exploring or discovering, as I put in my slides. And in there, the idea is you're going to interact with a person that knows about the business. We call this person a stakeholder, and you're going to do, for example, interviews with this stakeholder in order to understand the requirements. You're going to repeat these many times. You're going to come up with many features that need to be built. Then at some point you just go back home, and then you start to classify and organize those requirements, right? You're going to see that a few of them can be clustered together. Maybe you can call this like a subsystem. You can cluster them by users, and you start to notice that user with role A in the system does these kind of things, whereas users with role B, they do other things, right? Then you start to prioritize and to negotiate, and this is a very important step in large organizations, because you're going to see that you have requirements from different parts of the company. Probably each part of the company think that their requirements are more important than others, so you have to prioritize them. You have to remove conflicts that might happen, like if you build A, then B needs to change, and these kind of things. And you have to record those requirements using some nice language that everybody can understand, like UML. Then another distinction we made about requirements, because both of them are very useful when you're building software, but it's still nice to put them into different buckets, is what we call functional and non-functional requirements. Functional requirements are more about the features that the software will do for the final user. So this is more like, well, if I give this input to my software, this is the output I get. So I think the second bullet point there clearly explains to you what it means, right? What kind of services should my software provide? If it is Brightspace, for example, we can be to have a forum, to have an assignments features, and etc., right? So it's really related to the business. Or to the business rules, so to say. And non-functional requirements are more related to the kind of constraints your software usually has. For example, performance. My software needs to reply within 10 milliseconds. Or my software needs to be able to handle 50,000 users per second. So these are basically kind of constraints we have, and of course we will have to write software to support those constraints, but can you see that they are different from each other? Yeah, functional and non-functional requirements. Cool. That's a very important division that in practice really helps you when thinking about software architecture, software design, that we're going to see later. Then I basically mentioned the Forbes Plus that our book mentions, so I'm going to not dive too much into it because it's really well explained in the book. But basically, I use this. One can use this as a sort of checklist to make sure that your requirements has everything that is important. We saw that requirements can come from many different things, like for example legislative requirements. So maybe your software needs to follow some sort of law that your country has, right? And maybe these laws will give you requirements. So there are so many ways that a requirement can come in for us to develop. Then we discussed gathering techniques, and in here what we basically do is we need to talk to people that know the business, right? And by talking to them, I mean you can do linked reviews, so like one-on-one interviews. You can do focus groups where you just get together. There's a bunch of stakeholders, and all of us together, we understand the requirements. We can do observations and ethnography, more like researchers do. Say they emerge into the problem, they observe how people solve the problem in practice. You take notes, and then which are basically requirements, right? Our book also mentions, techniques like, well, you can explore who, what, when, where, why, and how, and these questions will help you to think about requirements and to interview people. Um, I'm also not going to dive too much because the book is quite clear on this one. Challenges that we observe in practice. So stakeholders often don't know what they want. We discussed this in the waterfall lecture, and this is still true here. So it can be really hard to extract the information out of the stakeholder, right? Um, Stakeholders speak business language, so they usually know nothing about software, and you have to do the translation, and you do this bridge actually, right, between what they want and what the software really does, and what stakeholders speak and what developers speak. So this bridge is pretty hard to be done in practice. And if you have different stakeholders, that happens a lot. So you work for a very large company. The very large company has many departments which you need to attend. They have different requirements. They express themselves in different ways. They have different priorities. So it is also the challenge of the person doing requirements engineering to make sure everything goes smooth, right? That those stakeholders, they kind of agree with each other. And then I guess the cool part of the lecture, which was UML, and UML is basically this common language that we can use to speak software. And what I really like from UML is that UML helps us to represent different levels um, of our software, right? And depending on what part of the software development we are, there's a specific part of the UML that can help you. So you can start from a very conceptual way of expressing yourself. Like at the beginning of your software, you only know domain concepts. You kind of don't know the technicalities, or you want to ignore the technicalities at that point. So UML helps you to basically represent the main domain concepts and how they are related. But then as soon as you understand a bit more, maybe you want to start diving in a little bit into the specification, so you can start thinking about subsystems and how those systems will talk to each other. Still, you don't care about the implementation of a single method in there, but you're now more, although closer to the implementation, is still high level, basically talking about modules and how they communicate. And finally, if you want to think of implementation choices and you feel like you need a language for this, UML also gives you some ideas on how to do it. Well, UML, some advantages, right? It reduces risks by documenting assumptions. This is what I like. So UML is this very large kit, and people have put a lot of effort on making sure that if you follow this recipe, so to say, yeah, the common problems will disappear in a way, right? Because you have a systematic way of documenting your software. It is a sort of industry standard, although with the agile movement, UML lost a little bit of its strength, but still quite popular. It is very well defined. It is open, so you can extend it. Then in this lecture, we mostly spoke about three different ways, three different parts of the UML. The first one was the use case, and in this one, it is a conceptual document, as you can see. And in here, the goal is to basically show the features that we want from our software and how those features are related and which actors or stakeholders interact with those features, right? So for example, in our Brightspace example, you see that students can see announcements, they can download content, they can hand in assignments, a TA can create an announcement, it can grade an assignment, a teacher can submit the final grades, so on and so forth. So in a picture like this, you can get a quick glimpse on what your software needs to do, the main concepts, and how those things are related. Important parts of this document, so actors, basically the stakeholders who uses those features. So in this bright space, there is the student view of the software, the TA view of the software, and the teacher view of the software, and they all see different things in the system, right? You have the use cases themselves, and they are basically the features um, that our software needs to do. We have relationships. I discussed a few of them. For example, include. Include basically means that, for example, in this example, hand in assignment includes fraud check. So whenever you hand in an assignment, a fraud check is always executed. So in a way, fraud check is part of the hand in assignment. But fraud check is something so big and so important that it deserves to be represented as its own use case. So then we extract fraud check out of the hand in assignment, and then we just put this relationship there. Is this compulsory? Do I need to, whenever a functionality is too big, do I need to break it into two and then use the include relationship? Well, yes and no, right? So if you feel like some feature is really growing up in terms of size and importance, it is nice to represent it as its own concept. It creates visibility, it creates awareness, and that's the beauty of this picture, right? So it is pretty hard to know the granularity. There's no right answer here. So what you need to do is to keep exploring, right? Those diagrams evolve over time. Depends on was another one that I discussed, and this basically means that one feature depends on the another. In this case, grade an assignment depends on a student handing an assignment, right? I cannot grade an assignment that was not delivered. And there are many others. Let me see what else I have in here. Extend and generalization. Extend basically means I have this feature, for example, see announcements, and there's a feature that basically extends or changes the behavior a little bit. For example, see exam related announcements. And in practice, you know that those two features are connected. But see exam related announcements is a very important feature for me. I don't want to put it inside of the see announcements bucket. So I split it and I say, well, this one kind of extends this see announcements feature. And there is the concept of generalization, right? So this basically means you have something that is more abstract, in this case, download content. But in practice, I want my student to download videos or slides, and those features are different. So I kind of have this abstraction that is called domain content, and I have concrete use cases that implement this abstraction. So showing generalization is important, right? Because it reduces our cognitive load. So maybe when discussing with stakeholders, we can only talk about downloading content. The specific ones, maybe we kind of don't care in some conversations. So it gives us more vocabulary to talk. I also show an example from this UML diagrams website, which is very cool. So you should visit it and see other examples. And of course, if you just look at that, the use case itself, you get the features, you get how they are related to each other, but they are not really specifications, right? And what we do is, for each use case in there, we then dive into it and we write use case specifications. These use case specifications basically detail the use case. And how do you do this? Well, we try to follow some sort of pattern, right, or template to do it. I show one template here. So let me go to the concrete example. So we have the use case name, the actors that play a role in there, a small description, priority, preconditions, postconditions. So preconditions are things that need to be there before I can execute my feature. Postconditions is what kind of big changes does this feature make in the state of my system, right? Then basic paths. So what happens in the happy path if the user just clicks on the right things? Are there alternative paths that I should take care of? Business rules. Are there something else that I didn't mention in the basic paths before, but we should follow? And then non-functional requirements. Is there something I should pay attention constraint-wise about this requirement? So, and that's how we do, right? And then we have many of those use case specifications. They describe the system, and we use them as a sort of a seed to start developing. Then another diagram I showed you, a lot of systems, a lot of systems and maybe subsystems or small parts of it can be represented as a state diagram. And the idea gets really easy to see. if you start thinking about a concrete example. So in this one, suppose you're building a bank ATM, so you put your credit card or your debit card, and then you do some operations with your bank, and the machine itself has some sort of state. For example, the machine is idle. It starts to do something as soon as the card is inserted. As soon as the card is inserted, there's some sort of authentication. The user selects the transaction, the operation he or she is going to do. The transaction happens, and then we are done. And the cool thing is that as soon as you start representing those states, we use this diagram to clarify requirements, right? So if you're developing this bank ATM, it can be really nice to think about the states that this machine will be at each part of the whole process. What do you need to know about this diagram? Well, these rectangles basically represent states. We have arrows, and those arrows have some sort of information in here, which is we call those arrows a transition, and we try to write down what this transition is about. For example, if you are in this off state, well, off means off, right? The machine is off. Then if the person turns on, then we go first to this self-test. And then after the self-test, as soon as the self-test is done, we go to idle, right? Card is inserted, so we are in idle, card is inserted, we go to some other state. If they cancel, we come back. We always have an initial state. We always try to represent the end state, which is when the main operation of that state, of that software is concluded. What else? And many other things, right? So for example, as in here, you can see that the person created what we call a super state, so a big state, and then inside of this state you have another state machine. That can also happen. But what matters about this diagram is that you're representing states and how you move from one state to the other. Yeah, in the lecture I gave you the example also the washing machine. As soon as you turn on your washing machine gets into the waiting for operation to be selected state or something like that, right? And then you select the operation. As soon as you press start, then the operation you selected the program you selected really starts, right? So as soon as you're developing this type of systems, thinking of state machines make a lot of sense. And finally, the last one I talked to you about is the activity diagram. And in the activity diagram, we try to represent some complex business process. A business process is usually composed of a sequence of activities in which one maybe only happens if the previous one happens. Maybe two things need to happen at the same time. And then, well, the activity diagram fits very well. So if you see this example in here, we are modeling the process order activity. It starts by receiving an order, then it checks if the order was accepted or rejected. So this diamond basically means we have a decision point in here. If it was accepted, we fill the order, and then as soon as we fill the order, the next step is let's do two things at the same time, because they don't have to happen only sequentially, right? And in this case, it's ship order, and then send an invoice. At some point we have to synchronize again so that we can continue. So in this case, we can only continue after the order was shipped and the payment was accepted, and then the order is closed, and then it is done. We got to the end of our activity diagram. So note a little bit of the difference between the state diagram and the activity diagram. The state diagram represents state, so a software is in that state, and in here we're basically representing a sequence of activities that need to happen so that some big business process happens. The notation is also very similar. So these rounded rectangles represent activities. Arrows represent how you move from one to the other. If you have a decision point, for example, you can use a diamond. If you want to have two activities that happen in parallel, you can use those bars over here. You can use the bars again to synchronize. So you're gonna come back to a sequential process. Your activities may produce something that is important, and that we represent by normal squares. For example, in here, send invoice basically creates an invoice, and this invoice is something so important that I want to represent it clearly in my diagram. And then the invoice is then used to the next part of the process. We also see this here, requested order, which is an information that gets in to receive order. So I'm basically saying, well, for this receive order activity to happen, we need to have a requested order. There are more examples in umldiagrams.org. Then we did that simple exercise. I'm not gonna go through it. You can do it. And then I basically showed you that UML has so many interesting things. We just focused on 3, but you feel free to explore the others. Then we discussed properties of a good requirement. So, and this is quite natural, right? There's you can feel what a good requirement is, but it's nice to formalize it. So a good requirement is clear, concise, easy to understand by both stakeholders and developers. It tries to be unambiguous, it tries to be consistent, and consistent means as soon as you have more than one requirement, are they consistent with each other? If I do A, can I do B, or do they conflict in a way? Prioritized, so you need to prioritize them, and verifiable. Can we make sure that this use case, as soon as it is implemented, it is correct? It makes what we want it to make. I discussed a few ideas, a few questions you can have to yourself on how to do validation. I think my slides are pretty clear about it. I'm not going to go into each one of them. We also discussed how to prioritize, and the Moscow method is the most popular one. And the ideal is basically for you to think of must-haves, should-haves, could-haves, and want-haves. I find this method really interesting at the beginning of the software development process. So you're still exploring and you're building your MVP, so your minimum viable product, and using those simple-ish techniques might help you separate what is very important from what is maybe important only later. And then we quickly discussed user stories. So user stories are the way agile people like to do requirements. They are, in short, a clear and concise description of a feature. A user story usually looks like this. As some stakeholder, I want some feature, so that then the value of this feature. For example, as a teacher, I want a report of all students so that I can give them bonus points. In a way, we are showing the actors, a summary of what this feature is about, and what value does it bring to your software. So in a way, this matches a little bit of some of the use case specifications fields that we had in our template, right? And then a user story also comes with acceptance criteria, which is basically where people describe their user stories in a bit more details. So in a way, this looks like the basic or alternative PAPs from the UML. So this is a complete example. But I think the main difference in practice between both UML and agile user stories is that in UML, we like to have this checklist in a way, so that we try from the very beginning to write not a very complete requirement, because we know that's impossible, but we try to, from the very beginning, explore the requirement a bit more. And in agile methodologies, usually teams are more okay-ish with user stories that are less complete, because in practice, given that you have an agile process in place, your product owner or your stakeholder is very close to you, so you can always ask questions. So in a way, you complement the lack of the lack of rigor in your user stories by having people near you, people that can talk to you and can give you feedback right away. But don't believe in this false idea that UML is rigid, and as soon as you write an UML, it doesn't change. Of course it changes. You can use UML inside of agile methodologies as well, right? A requirement has always to evolve. Everybody knows that. Then my slides goes into a few of best practices for writing user stories. Slides are very clear. I'm not going to discuss this as well in this video. This is the book I recommend you to read if you really like user stories. And then my final advice was, regardless of the language you choose, come up with a standard format and make sure that all your requirements adhere to these standards, right? This is going to really save you some money because you don't have to keep sending requirements back for more work and etc. Use consistent language, come up with your own vocabulary together with the stakeholder, right? Business terms are very important. Prioritize your requirements, distinguish between mandatory and desirable. Make sure the clear parts of the requirement are really clear. Do not assume that readers understand technical software engineering language. If you want your stakeholders to read your requirements and give you tips, well, it has to be written in a language that this person can understand, right? So you need to know your stakeholders a bit so that you can decide the language. Try to explain details in your requirement, like rationale. Why are we doing this? Why is this decision important? And this is particularly interesting as soon as you are doing some complex requirements, right? Some decision that is non-trivial. To understand why, just document it and validate your requirements. Um, then that was it. Yes, that was it. See you next lecture.